Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the previous sessions, we discussed about solving algebraic and transcendental equations by various methods. Also, linear system of equations by direct and indirect methods was discussed. And in continuance with that, we were discussing about interpolating the values, that is finding the y values from the inside x values. So, we are going to use Newton's forward and backward difference formula. Before that, we need the introduction about forward and backward differences. So, that introduction was also given. So, the objective of this session is to discuss about interpolating the values using Newton's forward and backward difference formula, that is finding the y values corresponding to inside x values, and then symbolic relationships between various operators will be discussed. Also, divided differences will be discussed, and the corresponding formula for divided difference, that is Newton's general interpolation formula, will be discussed in this session. A symbolic relationship is there between forward and backward differences. So, what is that symbolic relationship says? We have seen in the previous session that forward difference is given by del y naught is equal to y1 minus y naught, for example, and nebula y1 is given as y1 minus y naught. And so, using that we are going to relate with the shift operator E and the central difference operator delta, and then averaging operator mu, and then differentiation operator D. That is all these delta, forward difference operator, backward difference operator nebula, shift operator E, central difference operator delta, mu averaging operator, and capital T differentiation operator. So, there is a symbolic relationship between all these things. That is, I will just write down relationship between the operators, that is EYR is equal to, it is a shift operator, it shifts YR to YR plus 1. So, delta is equivalent to E minus 1 and E is equivalent to delta plus 1. So, this is one relationship between E and delta, and similarly nebula is equal to 1 minus e to the power minus 1. This is another relationship, and then mu is equal to 1 by 2 e to the power 1 by 2 plus e to the power minus 1 by 2, and delta is equal to e to the power 1 by 2 minus e to the power minus 1 by 2, and using E you can relate mu and deltas because we have the E formula as 1 plus delta, isn't it? 1 plus delta. So, mu can also be written in terms of delta, and delta can also be written in terms of small delta. This is small delta, central difference operator. Small delta can be written in terms of capital delta also. Okay. These are all operators we have to write in terms of equivalence, right? And delta is equal to nebula into E and is equivalent to delta into e to the power 1 by 2. And also we have mu is equal to mu in terms of delta root of 1 plus del square by 4, and for the differentiation operator capital D. So, E is equivalent to 1 plus h d plus h square d square by 2 factorial plus h cube d cube by 3 factorial plus etc. Okay. So, these are the symbolic relationship between the operators. So, E is actually equivalent to e power hd. Okay. These symbolic relations can be used to relate the forward difference operators, backward difference operators, central difference operator and averaging operator, differentiation operator and shift operators. Next, differences of a polynomial. Consider a polynomial of degree n, that is y of x is equal to a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus etc. plus an. And differences of the polynomial is del yx, which is equal to y of x plus h minus y of x, and this is y of x plus h is written as a naught x plus h whole power n plus a1 x plus h whole power n minus 1 plus a2 x plus h whole power n minus 2, that is subtracted with y of x, and then we have the ultimate this thing as a naught n h x power n minus 1 plus a1 dash, it is another coefficient x power n minus 2 plus etc. plus a n dash, it is another constant. Okay. So, we get the difference of the polynomial. Difference of the polynomial is a naught n h. So, if a polynomial is of degree n, the difference of a polynomial will be of degree n minus 1. In all the cases, a naught should not be equal to 0. So, from this we can note that if n plus 1 values are given, that is if x and y values pair, n plus 1 pairs are given, then an nth degree polynomial will be formed, and n plus 1th difference of nth degree polynomial is 0. For example, you have the first difference of the nth degree polynomial is n minus 1. So, second difference will be a polynomial of n minus 2 degree. So, like that it is getting reduced. So, n plus 1th difference of nth degree polynomial is 0. So, if n plus 1 values are given, then n plus 1th difference will be 0. That is we have seen that in a tabular column of 3 values, in a tabular column of 3 values x0, x1, x2, we could find out the tabular column only up to del square. So, afterwards it becomes 0. So, del cube of the values of a set of 3 pairs of values will be 0. So, if n plus 1 values are given, then n plus 1th difference is 0. So, if n values are given, nth difference is 0. So, using this we are going to construct a polynomial in x. Newton's forward and backward interpolation formulas. Interpolation must be with equal intervals. Newton's forward difference formula is given by Pn of x is equal to Pn of x0 plus uh. That is we are going to change the x values using change of origin and scale as x0 and h. So, all the values of x will be changed to u as x minus x0 by h. So that Pn of x is equal to Pn of x0 plus uh, y0 plus u del y0 plus u into u minus 1 by 2 factorial into del square y0 plus u into u minus 1 into u minus 2 by 3 factorial del cube y0 plus etc. x0 is the first value, h is the width of the interval, that is difference between two consecutive values. That is why we insist that the intervals are of equal width or equal intervals, so that we can find out the h values. Otherwise, for unequal intervals, Newton's forward and backward difference cannot be used. So, del y0 is y1 minus y0, del yn in general is yn plus 1 minus yn. All these have been discussed earlier, and then here again v is taken as x minus xn by h. So that Pn of Newton's backward difference formula is Pn of x is equal to Pn of xn plus vh, yn plus v into nebula yn plus v into v plus 1 by 2 factorial into nebula square yn plus v into v plus 1 into v plus 2 by 3 factorial nebula cube yn plus etc. where V is x minus xn by h and xn is the last x value, and nebula yn is yn minus 1. Nebula is called the backward difference operator. We shall use this illustration to understand the Newton's forward and backward difference formula. Okay. Using Newton's formula, find the value of y at x is equal to 46. You can see x values are 45, 50, 55, 60, 65 and 46 is to be found out. Y value corresponding to x is equal to 46 is to be found out, and x is equal to 46 is actually one of the front values. So, for finding y value at x is equal to 46, we use Newton's forward difference formula, and x is equal to 63 is finding y value at x is equal to 63 is somewhat at back. Therefore, we have to use Newton's backward difference formula for finding the y value corresponding to x is equal to 63. Okay. So, x values are given and y values are given. Let us find out. We shall construct this table, forward difference table. X values are equally spaced at 5. We shall find out del y, del square y, etc. First of all, we will find out del y, and del y is the first value is 96.16 minus 114.84 and it is minus 18.68, and it is written in between 96.616 and 114.84. The next value is minus 12.84, that is 83.32 minus 96.16, likewise minus 8.84 and minus 6, and then del square value is minus 12.84 minus of minus 18.68, and this value is 5.84, 4 and 2.84. Then 4.4 minus 5.84 minus 1.84 and then minus 1.16. Del power 4y is 0.68. So, for when 5 values are given, fifth difference will be 0. Therefore, we stop the procedure at del power 4 y. So, this is the forward difference table, and we take u is equal to x minus x naught by h to find y when x is equal to 46. So, u becomes 46 minus x naught is the first value, that is 45, and h difference is 5. So, u is equal to 1 by 5, that is 0.2. Okay. And h is we have all the other values as it is. So, we shall use the Newton's forward difference formula. Newton's forward difference formula is Pn of 46 is y of what is the formula? We have y naught plus u into del y naught plus you have the value as 0.2, and y naught is the first y value 114.84, and del y naught is I shall show it this in the tabular column. Okay. These are x naught, x1, x2, x3, x4, and this is y naught, y1, y2, y3, y4, and this value is del y naught. The first value is del y naught, and this is del square y naught first value, this is del cube y naught, and this value is del power 4 y naught. Okay. So, we take the values as it is. I will just write down, and the calculations values. Y naught is 114.84 plus 0.2 into minus 18.68 plus 0.2 into 0.2 minus 1 divided by 2 factorial into 5.84 plus 0.2 into 0.2 minus 1 is 0.8 minus 0.8 minus 1.8 divided by 3 factorial into minus 1.84 plus 0.2 into minus 0.8 into minus 1.8 into minus 2.8 divided by 4 factorial into 0.68. Okay. And this value after calculation comes to be equal to 110.526. You can see Pn of 45 that is given in the question is 114.84 and Pn of 46 is we have found out by Newton's forward difference formula is 110.526. That is the y values will be nearer to the given y values. Okay. When it is 114.84 for 45, for 46 it is 110.526 is the correct one. Okay. Similarly, we can find out by Newton's backward difference formula Pn of 63. Again, the same tabular column can be used for writing down the nebula values. So, this is nebula y1, this is yn, right, and this is y54 and this is nebula y4, this minus 6, and 2.84 is nebula square y4 and minus 1.16 is nebula cube y4 and this value is nebula power 4 y4. And Newton's backward formula can be used to find out 63, to find out y value corresponding to x is equal to 63. According to the formula, it is yn. So, before that we need to calculate what is v. V is x minus xn by h and x is 63, xn is the last x value, 63 minus 65 divided by h is 5. H is 5 and this v value comes to be equal to minus 0.4. Okay. So, first of all, according to the formula it is yn plus h into nebula yn. So, yn is the last y value 68.48 plus v into minus 0.4 into nebula yn. Nebula yn is the nebula y4 minus 6 plus minus 0.4 into minus 0.4 minus 1 by 2 factorial into nebula square yn is 2.84 plus minus 0.4 into minus 0.4 minus 1 minus 0.4 minus 2 by 3 factorial into minus 1.16 plus minus 0.4 minus 0.4 minus 1 minus 0.4 minus 2 minus 0.4 minus 3 by 4 factorial into 0.68 and this value comes to be equal to 70.58. This is using Newton's backward difference formula. In not only Newton's forward and backward difference formula is used not only to find out the y values for corresponding x values, it can also be used to find the polynomial from the given data. That is, you can see, I quickly go through this illustration. X values are given to be equal to 2, 4, 6, 8, 10 and y values are 0, 0, 1, 0, 0 and x values are equally spaced at h is equal to 2 and the del y are calculated. Del y is 0, 1, minus 1 and 0 and this is 1, minus 2, 1, minus 3, 3 and then 6. Okay. So, the formula is written, Newton's forward difference formula is written. The only thing is where in the place of u usually we will substitute the corresponding x value for which y has to be found out, but here x will be kept as x itself, that is all. So, u is equal to x minus x naught by h. X naught is 2 and h is also 2. So, u is equal to x minus 2 by 2. Wherever u is there, you have to substitute these values. And since most of the values are 0, it is very easy to just cancel this and we get only u into u minus 1 by 2 factorial into the corresponding del square y naught value. So, like this these values are written here and after simplification we get the polynomial as x power 4 minus 24x cube plus 196x square minus 624x plus 640 divided by 64. To check whether the polynomial we have found out is suitable for this data or whether you have found out correctly, we can verify it by substituting any of the given x values and so that we will get the corresponding y value. Okay. For example, in the question corresponding to x is equal to 2, y value given as 0. Let me check in the polynomial just found out, if x is equal to 2 is substituted, we should get y is equal to 0. So, Pn of 2 we get the calculation as 0. So, our polynomial is correct and this is how we will verify whether the polynomial we have found out is correct or not. Okay. And then divided differences or central difference. There are actually two formula, but Newton's general interpolation formula for equal intervals has been specified in your syllabus. Lagrange's interpolation formula is used for unequal intervals. A divided difference or central difference is given by the formula. First, divided difference of x1 for x0 comma x1 is defined as this is also pronounced as del x1 of f of x0 is f of x1 minus f of x0 divided by x1 minus x0. In terms of y, it is y1 minus y0 divided by x1 minus x0, that is del y0. Similarly, for the second one, first difference value, del f of x1 for x2 is f of x2 minus f of x1 by x2 minus x1, and second difference is del square f of x0 for x1 x2 values, f of x1 comma x2 minus f of x0 comma x1, and here the values are represented as f of x0 comma x1 and this is represented as f of x1 comma x2. So, del square f of x0 is f of x1 comma x2 minus f of x0 comma x1 divided by x2 minus x0. So, this is del f of x1 for x2 and del f of x0 for x1 divided by x2 minus x0. This is divided difference formula. Using this we have the Newton's general interpolation formula. Let us take the 4 values x0, x1, x2, x3, corresponding y values are y0, y1, y2, y3. Let us see how the table is constructed. y0, y1, y2, y3, delta y is y1 minus y0 divided by x1 minus x0, and here this is y2 minus y1 divided by x2 minus x1, and here you have y3 minus y2 divided by x3 minus x2, and this is represented as del y0 and this is del y1 and this is del y2. Okay. And this is actually f of x0 comma x1 and this is f of x1 comma x2 and this is f of x2 comma x3. Okay. Similarly, del square y is calculated and this is del y1 minus del y0 divided by, you can see what are the extreme x values, x2 minus x0. Here you have del y2 minus del y1 divided by x3 minus x1. Okay. And then we have del cube y0, del cube. Another table column, we have del cube y, that is del square y0 minus del square y1 minus this is represented as del square y1 and this is del square y0. Then we have the next row, that is del cube y, that is equal to del square y1 minus del square y0 divided by x3 minus x0. I will just write down the formula. Y0 is equal to del square y1 minus del square y0 divided by x3 minus x0. That is going to be the last one value. Okay. Using this we have the Newton's divider difference formula, also called as Newton's general interpolation formula. Okay. So, f of x is equal to f of x naught plus x minus x naught into del, here the intervals need not be equal. This is f of x naught plus x minus x naught into del f of x naught plus x minus x naught into x minus x1 into del square f of x naught plus it goes on, etc. In this session we discussed about interpolating the values using Newton's forward and backward difference formula, and an example was worked out in finding the y values corresponding to front x value and backward y x value. Also, symbolic relationships between various difference operators was discussed, and a brief about divider difference and the formula corresponding to divider difference, that is Newton's general interpolation formula, was also given. Based on the discussion in this session, the following question may be posed. Write down the relationships between delta, nebula, shift operator E, central difference operator delta, averaging operator mu and differentiation operator D. What is meant by divider difference? Write down the formula corresponding to it. Using the following table, interpolate the values of f at x is equal to 15 and at x is equal to 45 using Newton's forward as well as backward interpolation formulae. That is, x values are given 10, 20, 30, 40, 50. F of x values, that is y values, are given 46, 66, 81, 93, 101. Thank you.